I am Robert Guarini, Bob Guarini, whatever. I'll answer all those. And the president and CEO of Philadelphia Electrical Equipment Company. We were that before the utility changed their name. So they stole our name. We didn't steal those. And I'm here by invitation from General Electric, GE, and in particular their intelligence solutions platform, and more specific, their relationship to the industrial internet, which is what the ARC group is addressing in this forum. And as it relates down to, when we get to hardware, the field agent, which we'll get into later. I have visual aids. And for us, what it gets down to is to, as it relates into our system, which is the ICE-style PEECO switchgear. So to give you a little idea, Philadelphia Electrical Equipment Company, we started 34 years ago, and it's power generation. It's not the kind of power generation that people like to hear about. We're not in the 2% market of alternate energy. So we've done windmills, we've done PV, but that's not what we like to do. We're the dirty fingernail engineers. Most of our application is in power generation in the mid-level, like not from Home Depot, not nuclear plants, somewhere in the middle, but not in the area of straight standby generation above that. Not hospital standbys, apartment building standbys, something above that, but in an area below what most people think of as utility. So say small utilities, medium utilities are part of our client base. Most of the equipment we deal with is on the control side. So we're seeing power generation, you're seeing a combustion turbine, you're seeing a synchronous generator, you're seeing something probably in the 5 megawatt range. Our concentration always has been since day one for 33 years to really get into the control side, not into putting together a generator set. The evolution of reciprocating engines, natural gas, diesel, number 6 fuel, whatever, has changed very little until just recently. Basically, it's just slapping a synchronous generator to a reciprocating engine and making electricity. So I want to try to give you a little presentation of where we came from and where we're going and where we try to keep going and why we have to be in places like this that we are today, even though we're just making electricity. So this is my first visual aid. We're very proud of this. This is what you call a printed circuit board. So this is actually, we've actually built hundreds of these and they've been installed and operational around the world for decades. So that said, this was cutting edge technology. Absolute truth when we started. So I guess we've moved on a little bit from that. But today, like I said, generator sets, with the exception of some simple changes like the reliability of a diode and changing from brush type to brushless generator sets, there hasn't been much change. On the engine side today, there's just recently become a lot of change, getting into electronic data acquisition for engine parameters and things like that. We kind of broke this down into, say, 5 categories of our client base. Nothing specific about the categories, nothing special, but we kind of grouped them so we're just not talking in generalities. So can I have the next slide? I have to do it? I have to do it. Okay. Just push the button, go forward, forward. Oh, yes, that's the next slide. Okay, so that's not the next slide. That's the third slide. Okay, yeah, that was the next slide. That's the first slide. That's the second slide. Okay, prime power plants. Standby plus power plants. Category 2 users. CHP, cogeneration. Demand spot market response. They all have a commonality in so much as power generation, be it combustion turbine, reciprocating engine, various kinds of fuel, methane fuels for landfill gas, number 2 diesel, natural gas, etc. But the application of the generator set for its use is completely different. Yeah, they all make electricity. But prime power plants is pretty much self-explanatory. They're supposed to run all the time, and they're supposed to generate a bulk of power on a continual basis. Standby is simple for people to understand. The lights go out, the lights come back on again. An industrial plant, hotel, hospital, whatever. For us, standby plus plus means that you've got to have that added assurance of reliability. So now we're in standby, but we're in standby where if the lights don't come back on or if the power doesn't come back up again, you got a real problem. Real problem meaning you've lost a pharmaceutical process, it's $1 million. You've cured the concrete in a concrete plant, you're going to have to break up the kiln. You're going to have to, one of our clients is AT&T, undersea cable, running from Europe, touching base in St. Thomas, St. Croix, and then running down and running up north, tying into the mainland. Well, you know, the WAPA, which is the utility down in that area, isn't the most reliable. So standby, yeah, but standby running a lot of times during the month and having only an 8-hour window to get the power back up. They had 8-hour batteries. So that's standby plus plus. Category 2 users are usually specific to airports, that type of an environment where you can see a problem coming. You can see, and I don't necessarily mean hurricanes, but maybe even thunderstorms, snowstorms, this kind of thing, where you know that the dependability of your power on site generating power is much more reliable than the utility. You sit there and wait for the utility to go out. You put your system online and you're running and you monitor it, and that's, you'll see later, one of the tie-ins to what we're talking about here, data acquisition, utilization of the data you get, quick response to make sure that the system is going to stay up and running and be more dependable than the utility. CHP cogeneration is kind of the same thing. This is a broad brush audience, so normally I wouldn't explain that, but since there's a lot of clients and there's a lot of people in here from different backgrounds, CHP is the old cogeneration that came and went some years ago. It tried to rock it up and it didn't have a fit and disappeared. So it's come back today in the same thing, but now it's called CHP, or combined heat and power. That's where we have a real application for much more data acquisition, in so much as combined heat and power takes two systems and they have to operate together. And they can't operate autonomously, because if you're generating electricity, then you're dispelling power. You have to reject the power from the system, and if you're not rejecting enough power, then you can't make any more electricity. So you can't have one without the other. So you can see how there's two systems now have to tie together. So that's cogeneration. And demand spot market response. Same thing, you can actually exclude power generation from that if you have a 10 megawatt light switch. So in a lot of tariffs in various utilities in the United States, particularly in the Northeast, you can buy into a tariff meaning how you're going to buy your electricity. So you can buy into a tariff where you can purchase electricity relatively cheap as long as it's available. Then when it doesn't become available, you're also at risk to pay an extremely high price for that kilowatt hour chunk of power, and there's nothing you can do about it. You can buy in straight cost power, and then you really don't have a demand spot market response situation. So demand spot market response is, you have a tariff, and I'm going to give an example now, even though I had it for later. A university, particular Temple University, is buying power at the easy market time of 9 cents a kilowatt hour. Years ago, we developed and put in a system, which would have been this system today, but it wasn't available. It's a little bit past this, where we actually monitored the energy cost right off of an internet site, which wasn't even designed to do that. But there was no device and there was no industrial internet. There was no other way to do it. So we'd monitor the price and we'd sample it on 10-second intervals. Well, if two sequential 10-second intervals saw a price increase and we didn't grab the 10 megawatt power plant and put it online or turn the 10 megawatt switch off, the price of energy went from 9 cents to 90 cents. and would stay there during the grid stress period, which would be hours. So you do the math and you see it comes up quick. Okay, now we can do the next slide. So, prime power plants, again, self-explanatory, but there's a whole different set of parametric needs necessary for the industrial internet in each one of these applications. Prime power, yes, has a big relevance towards preventative maintenance, predicting and reacting to the needs of the grid, if it's a prime power plant, if you're in parallel with the grid or not in parallel with the grid, and obviously reducing skilled workforce. In today's engine generator set, only in recent years, can you now acquire all of the engine parameters and more from that system that you see there today. And it can be done electronically. And it's in Tier 2, Tier 3, Tier 4, I and F means the emissions level standard engines. You can grab that data out of CAN bus, which is already available to the engine. Massage it into the system through the PLC, take it and grab it and send it out on the industrial internet. You can analyze the information out there from remote source, and as Greg talked about in the mix of coming back with information, solve the problem. The standby plus plus I talked about a little bit with relationship to some of the client bases. Our client base, like I mentioned, AT&T having to do with the submarine cable. Okay, so it can't be down. And I don't know if many people know out there that, like, we talk about the satellite and all, but there's still an absolute tremendous amount of information that goes via the undersea cable. It's not. I myself, as soon as when we got involved with them, really thought that there wasn't much left and that was an outmoded technology, and it's certainly not. So, but different client bases, like what we have here, pharmaceuticals. We have a large pharmaceutical base for our clients. Because again, the process of being in a batch for developing some particular drug and going down, they lose that entire batch. One of our clients was Johnson Matthey also. You don't think of them as a pharmaceutical, but they developed the drug that has to do with stopping the heart. And, when you're in the process of doing something like that, you want to make sure power is available. Category 2 we talked about, but it's not just airports. Anybody that wants to, there's a lot of airports. I mean, Andrews Air Force Base, all the military bases go to Category 2. They go into generating all their own power at the time of possible problems. And you can see there, it's got a tie-in to, a very big tie-in to utility conditions and what's going to happen if the utility goes out. And like I said before, there's nothing special about these category breaks. It's just that their application for what we're doing in our I-style solution, I hate that word, our I-style solution with our product that we use from GE, it's just the application that makes the data acquisition, analyzing the data, and responding to the data different. The data is different, but for us, the power generation and control packages are the same. Combined heat and power cogeneration, we talked about it. So in a system like this, cogeneration means the production of electricity with the simultaneous production of a thermal product. So I explained briefly that, like, you can generate electricity, you can just expel the thermal product to atmosphere like you do in an automobile and many other places. But if you can recover that product at the same time, you're way ahead of the game. A reciprocating engine of any type, diesel, natural gas, etc., is only about 30% efficient on fuel cost. The other 30%, give or take, don't hold me to the exact 100%, goes up the stack, and the other 30% is in radiated heat, jacket water, and other radiated heat. So you can see if you can get close to generating power based on purchasing fuel, any type of normal available fossil fuel, and then recover that extra heat component or part of those extra heat components. Essentially, it's for free. Nobody can generate power cheaper than you can buy it from the utility in any particular utility environment. A lot of people up there are making sure that doesn't happen. But you can get close. So if you can do cogen and do it right, you can recover a lot of energy. But now you got to think about it. Now, not only do you have to worry about the engine generator set, all the mechanical components, the thousands of moving parts, along with the generator and its control and excitation, whether you're parallel with utility or not, now you got the whole heat process. So the heat process, like in our systems, will take, and on our HMIs, by our PLCs, by the field agents, we'll put all that information together because they are not exclusive of each other. And you don't have much time to react. Yeah, electrical and thermal needs. And obviously, again, reduction in skilled workforce. And in this application, it's multi-skilled workforce. You don't just have to have somebody who's an electrician. He's got to be an electrician. He's got to be familiar with the thermal product and know how to handle it and know the possible problems he could get into. We talked about Temple University. A lot of clients, we have a lot of university clients, and for similar, if not identical, applications. Harvard University, Temple University, we've done Penn State, we've done some stuff at Villanova. So that's why we threw these in particular categories. Tracking gas, utility, and spot market trends. So some of our customers can take advantage of a couple different areas of the savings we're talking about at times, actual dollar savings. We've even developed like a speedometer that we can put up on the HMI that'll monitor, how much money you're saving, or if you're going into the orange area where maybe you're not saving as much. But it all ties into what we need to do. We got to get away from this, and we got to get into this. We have a lot of familiarity since we've been in power generation control for years, having to do with going into the PLC platform, expanding the PLC platform, and that's all well and good, but it stays within the client's base, the client's operational site. The idea now is to get it out and get it back in a timely manner. Other items, let me go to the next slide, because now we're going to talk about downtime. So downtime, everybody's familiar with, and we put together that, $1.6 million per hour based on a Gartner estimate, but it's obvious everybody can understand that. But sometimes there's other things in there that are going to cause downtime that may not be so readily understandable. We all know it's supposed to be a certain temperature, it's supposed to have a certain output, it's supposed to do this at a time, that at a time. Last year, about a year and a half ago, we got involved in a job in Israel where they were losing alternators. The back end is the alternator. So they're losing alternators, 500 kilowatt alternators that were generating 4160 volts, and they couldn't understand. They went through 10 alternators, actually. This was a government-related missile defense situation. They went through 10 alternators and took us over there on a Tiger team to try to figure out what the problem was. So the 5 entities, myself included, we spent about a week and a half testing and coming up with all kinds of ideas and couldn't come up with the reason why these alternators were failing. So on the way back in the plane, I took what you could have had available via something like this today and just analyzed the parameters. What are the common parameters of why these things are failing? Where are they? What are they doing? How are they operating? What's the operating potential of the alternator, et cetera, and you put them all together. Like an old Villanova professor told me once, you don't have to solve problems. All you have to do is identify the problem. The solution will find itself. So what was happening was there was a situation called Corona, which was resulting in partial discharge and ultimate failure of the alternators. Not going to get into that. That's a whole discussion in itself. But it's important today that now there's another parameter that hardly anybody is even addressing in today's world, which is catastrophic failure in a very short period of time. Unless it's identified quickly, the unit is taken offline, and the situation is resolved. That's a situation that would occur in something like this. There's a 265 amp, 15,000 volt rated underground 3-phase power cable. We installed 7 miles of that in installation in Prudhoe Bay in the North Slope. And we had to tie in a parallel fiber line to tie the 2 power plants together because there was no other way of doing it. Well, a couple of these, a lot cheaper than duplex 7 miles of fiber cable. So it was another thing that we couldn't identify, and we couldn't control the situation. Have my own time, Tom. I'm done? Oh, quick? Okay, all right, quicker. A little quicker. Here's our old operator. That really is my dog, and that really is one of our panels, and he really was up there, even though I gave him a little help. So the idea is, again, the whole purpose of the talk here is we're trying to go to an evolution, a new evolution of solving a lot of problems. We're taking the information from there to there, we're putting it on the iPad, and I do have the screens up here, and getting it where it's got to go. So we're trying to get away from, yeah, okay, most operators are a little better than him, and this is relatively recent, but it's still antiquated, and you're only talking about 2-3 years old, and great, that's a great display, it stays right there. It stays right there in the power plant, and you assume that the guy that sits in there, and they do have 2 people operating this power plant, that sits in there bored to death for day after day after day, is going to respond and do what he's got to do when it has to happen. Well, it's not going to happen. So he's so bored that, we'll never even see the alert probably. So this is a replication of what we've seen before here, and basically tying everything together. We're trying to get the information which we can acquire now, put it in a platform that we can transmit now, get it there timely, and bring it back. This is part of the screen development where we're trying to take that static display in the HMI at that power plant and get it out where it's more visual to other people that can see it, and including into a solution in our iStyle system where we can actually monitor for the customer can monitor themselves. Each client can monitor things himself on a PC or a smartphone or an iPad, and we can monitor them all. So we try to oversee them and can respond in a better manner and maybe quickly. We talked about the various customers, clients, hospitals, all the cogen, all the 5 categories and more that I talked about before. One of our clients, we had to put that in there. I'm from Philly, that's a Philly cheesesteak. So believe it or not, one of our clients, Astra Foods, we put a system in there for 3 years ago, and his payback was about a year and a half on it was about a $3 million expenditure for capital, and he actually cuts up all the beef for production and distributes it to all the places that make Philly cheesesteaks. And he's extremely happy with it, invested in himself, an old Greek, and that's a type of production client. Natural gas fuel cogeneration, we talked about that. The cost of energy follows the price of natural gas, right on the same curve. So if you can react and buy natural gas at the right time, generate electricity, or don't buy natural gas at the wrong time and buy electricity. We have algorithms in our iStyle system that do just that. You'll follow the cost of natural gas, follow the cost of energy. When the client can run, and some clients run a portion of the whole operating year and have invested millions in the power plant. Forget the fact that he gets standby for nothing. That's just a plus. So at times when he can buy natural gas, he'll buy natural gas and make electricity. At times when he can't, he buys electricity. Sometimes they're close and you can buy, sell at the same time. So that's me. But anyhow, that's the idea. We've had the ability that not necessarily you can sit somewhere else, but somebody else is watching the system, and not more than once or twice or 3 times we've had to go to clients and they just have no interest. Okay, I understand we have an alarm, but I also understand we're not making mistakes, or we're not doing this. Fix the problem. Didn't even know we had it. Take care of it. I got things to do. Well, that's kind of the idea. And reduction in energy cost, yeah. Even though I say we're fossil fuel, all our combined heat and power systems are sold with a carbon footprint reduction part of the sales quote. I'm not the sales guy, so I'm not getting into that. But essentially we do. We do save energy, and we do get a lower carbon footprint. All right, another one of our clients, 2 technicians. We've been there for years, and I don't know if any of you heard of Longwood Gardens. Very fancy, run by the DuPont family to the tune of literally hundreds of millions of dollars. And believe it or not, the problem there is to not lose power for any considerable period of time, understand what the system is doing, standby system plus the 3 megawatt PV, plus any of the thermal systems to keep orchids that are worth millions of dollars alive. They don't want an orchid that's worth millions of dollars to die. Am I running over? I'm done? Hold on, I can see if I get any really good stuff at the end here. All right, just a quickie then. Like you said, this was a final note from me, and it's true for our customers. Buy the results from PEECO. Don't buy the product. Buy the results of what we have to offer, and part of that is for us to stay on the top of the wave when it comes to design. But you're right, buy the results of what we're selling, not the product. Thanks, sorry I ran over.